Welcome back to Code with Festus, where ideas turn into code. In the previous video, we talked about data types and variables. We learned how Python stores information, how it understands numbers, text, and collections, and how we can organize data in meaningful ways. But here's the thing, data by itself does nothing. A program becomes useful only when it can make decisions and repeat actions. That's exactly what control flow allows us to do. Control flow is what turns Python from passive script into active problem solver. It allows your code to respond to conditions, react to user input, and perform repetitive tasks effectively, efficiently. In this video, we are going deep, not just surface level explanations. We'll explore how Python decides what code to run, how it handles multiple conditions, how loops really work, and how you can control them using tools like break and continue. By the end of this video, you not only understand control flow, you will think in control flow, and that's a major milestone in your programming journey. What is control flow? By default, Python executes code sequentially, top to bottom, one line after the other. This is called sequential execution. But real-world problems are rarely that simple. In real life, you constantly make decisions. If it's raining, carry an umbrella. If your alarm rings, you wake up. If your phone battery is low, you charge it. Control flow gives Python this same decision-making power. It allows your program to ask questions, evaluate conditions, and choose different paths depending on the answers. These questions always evaluate to a Boolean value, either true or false. Without control flow, programs will be static and predictable. With control flow, programs become dynamic, interactive, and intelligent. Let's talk about Booleans. Every decision in Python is built on Booleans. A Boolean value can only be one of two things, true or false. In Python, these values are capitalized, true and false. Booleans usually come from comparisons. Is 10 greater than 5? That's true. Is 3 equal to 7? That's false. Whenever Python evaluates a condition in an if statement or loop, it is checking a Boolean behind the scenes. If you understand Booleans, control flow becomes much easier to reason about. If statements, that's making decisions. Let's start with the simplest form of control flow, if statements. You've seen this example over and over through this series. Age equal to 20. If age greater than 18, print you're an adult. Python evaluates the condition age greater than or equal to 18. If the condition is true, Python executes the indented block of code. If the condition is false, Python skips it entirely. Indentation is not optional in Python. It defines the structure of your code. The indented lines belong to the if statement. Think of indentation as ownership. Everything indented under if belongs to that decision. This design makes Python code extremely readable, but it also means indentation errors can completely change your program behavior. Else and ELIF, multiple decision paths. Most decisions aren't binary. Often, there are multiple possible outcomes. That's where else and ELIF come in. Consider this example. Score equal to 72. If score greater or equal to 90, print grade A. ELIF score greater or equal to 70, print grade B. ELIF score greater or equal to 50, print grade C. Else, print fail. Python checks these conditions from top to bottom. The moment it finds a condition that evaluates to true, it executes that block and ignores the rest. This means order matters. If you place conditions incorrectly, your program may still run but produce incorrect results. This pattern appears everywhere: grading systems, pricing tiers, permissions, feature flags, and validation logic. Nested if statements. Sometimes decisions live inside other decisions. This is called nesting. Example: age equal to 25 has underscore ID equal to true. If age greater than 18, if has ID, print. If age greater than 18, inside indentation if has ID, print else granted, else print ID required. The outside indentation else print too young. Nested if statements allows you to express complex logic clearly. The key is readability. If your nesting becomes too deep, it's often a sign your logic can be simplified. Comparison and logical operators. Comparison operators allow Python to compare values. Double equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Logical operators allow you to combine conditions, and all conditions must be true, or at least one condition must be true. Not reverses the condition. Example: if age greater or equal to 18 and has ID, print access granted. These operators mirror how we reason in real life. Python just enforces them strictly. While loops, repeating until a condition changes. A while loop repeats code as long as a condition remains true. Example: count equal to 1. While count less than or equal to 5, print count. Count plus equal to 1. Before each iteration, Python checks the condition. If the condition becomes false, the loop stops. While loops are useful when you don't know how many times things should run, like waiting for correct input or retrying an action. Always ensure something inside the loop changes the condition, or you risk creating an infinite loop. For loops, iterating over data. For loops are designed to iterate over sequences like lists, tuples, strings, and ranges. Example: colors equal to red, green, and blue. For color in colors, print color. Python automatically handles iteration and stopping. You can also use range. For I in range 1, 6, print I. For loops are ideal when processing collections, files, records, and datasets. Break and continue. Break exits a loop immediately. Continue skips the current iteration and moves to the next one. Example: for number in range 1, 10, if number equal to 5, break, print number. These tools give you fine-grained control over loop behavior. Match statements. Python introduced match statements as a cleaner alternative to long if-else chains. Example: status code equal to 404. Match status code. Case 200, print sources. Case 404, print not found. Case underscore, print unknown status. Match statements improve readability when handling structured conditions. Putting it all together. Real programs combine loops and conditionals. Control flow is how Python processes data intelligently and efficiently. This is where programming starts to feel powerful. Up until now, we've talked about what control flow is and how the syntax works. But this is the point where many beginners get stuck. Not because the syntax is hard, but because they don't yet think in logic. So, in this section, we are going to slow down and focus on something far more important than syntax: how to think like a programmer using control flow. Because real programs are not written line by line from memory. They are written by breaking problems into decisions and repetitions. Problem 1. Validating user inputs. Let's start with a very real problem. Imagine you are building a simple program that asks a user for their age. You want to make sure the user enters a valid number before program continues. Now, think about this logically. The program must keep asking until the input is valid. That means repetition. Loop. The program must check conditions. That means decision making, if statements. Here's how that looks in Python. While true, age equal to input, enter your age. If age.isDigits, print age accepted, age, break. Else, print invalid input, Please enter a number. Let's break this down carefully. We start with while true. This creates a loop that will run forever unless we explicitly stop it. Inside this loop, we ask the user for input. We check whether the input contains only digits. If it does, we accept it and break out of the loop. If it doesn't, we print an error and the loop runs again. This is perfect for real-world use case for while, if, and break. And notice something important here. We didn't know how many times the loop would run. That's why while was the correct tool. Problem 2. Using continue for cleaner logic. Now let's say we're processing a list of numbers, but we want to skip invalid values. Example, numbers equal to open bracket 10, 20, minus 5, 30, minus 1, 50, close the bracket. For num in numbers, if num less than 0, continue, print num. What's happening here? Python loops through each number. If the number is negative, we skip the rest of the loop. Python immediately jumps to the next iteration. This is what continue is for. Instead of wrapping everything in if blocks, continue lets you filter early and keep your logic clean. This pattern is extremely common in data processing, validation, filtering user input, ignoring edge cases. Cleaner logic means fewer bugs, better readability, easier maintenance. Now let's talk about nested control flow, because this is where beginners often panic. Here's a realistic example. Is _logged_in equal to true? Is _admin equal to false? If is logged in, if is admin, print welcome admin, else print welcome user, else print please log in. Read this like English. If the user is logged in, if they are an admin message, otherwise user message. If they are not logged in, ask them to log in. Nested logic is not bad. Unclear nested logic is bad. As a rule of thumb, if you can read it out loud and it still makes sense, you are doing fine. If you get confused reading your own logic, it's time to refactor. Match versus if-ELIF when it matters. Let's revisit match, but this time with intent. Imagine handling user commands. Command equal to start, match command. Case start, print, starting system. Case stop, print, stopping system. Case restart, print, restarting system. Case underscore, print unknown command. Could this be done with if-else? Yes, but match reads cleaner, scales better, reduces mental load. Here's the rule. Use if-else when conditions involve logic. Use match when conditions involve fixed pattern or known values. That's thinking like a programmer, choosing tools intentionally. Here's the mindset I want you to take away. Every program can be broken into decisions, if, ELIF, else, match. Repetition, for, while. Flow control, break, continue. When you sit down to write code, don't ask, what syntax do I need? Ask instead, what decision does this program make? What makes it repeat? When should it stop? Once you answer those questions, the code almost writes itself. Before you move on, try this challenge. Write a program that asks the user for a number. Keeps asking until they enter a valid number. Prints whether the number is even or odd. Stops once a valid number is processed. If you can do this, even partially, you're officially thinking in control flow. Control flow is not about memorizing keywords. It's about teaching your computer how to think step by step. Once you master this, everything else in programming becomes easier. We've just completed a deep dive into control flow. You now understand how Python makes decisions, handles multiple conditions, repeats actions, controls execution flow. Control flow is the backbone of programming logic. In the next video, We'll build on this foundation by introducing functions, reusable blocks that organize your logic cleanly. Keep practicing, keep experimenting. I'll see you in the next one. Happy coding.